So erosion within streams, I think it's very important to understand that erosion is a natural process. All landscapes erode. Streams over time adapt to the amount of water that is going through them. They'll down cut and they'll widen and they move back and forth. They are very dynamic systems. But over time, a stream reaches a state of equilibrium. The sediment eroded approximately equals that deposited. As that stream moves over, it erodes sediment, but then on the inside of the stream, sediment will be deposited. You look at this system, and there's a lot of indicators that show that the Minnesota River is out of balance. It's out of equilibrium. The first indicator is trees. If you look on this river, you'll see dead trees lining the banks. You'll see dead trees out on the sandbars. And what happens is, as rivers get out of equilibrium from, in this case, increased flow volume, a river's going to do one of two things. It's either going to cut down or it's going to widen. You can see that you got a lot of sand and there's a lot of gravel, a lot of boulders in the stream bed. Elevationally, this river is almost at gradient with the Blue Earth River. It really can't cut down any further. So what's happening is this river starting to widen. As it widens, trees fall in the river. A second indication that this system is a little out of balance, right to my left, you'll see a couple of pieces of culvert that are in the river. And you got to wonder, well, where in the heck did they come from? Come here, I'll show you. We've got the outlet of a gully to my right. You can see upstream a little bit, or up gradient, you can see a bridge. Once upon a time, those culverts were basically where that bridge was. There was dirt on top of the culverts. The flow that came down this ravine was able to go through those culverts. As more and more flow was added to the ravine system, there's a lot of, if you get to the top of the ravine, a lot of agricultural land, a lot of artificial drainage coming from these agricultural lands going to this ravine. Either a large storm or just this cumulative impact of increased discharge over time, increase the energy in the system, eventually knock these culverts out.